they're telling us that this function has at least one rational zero. Really, it needs to have at least two for us to be able to solve something like this, frankly. And the possible zeros would be have a numerator that had a factor that was a factor of 10, so it could be 1, 2, 5, or 10, and a denominator that's a factor of the lead coefficient. So just like always, it's a factor of the constant divided by a factor of the lead coefficient. These are all the numbers we can get that would be the combination of these: 1, 2, 5, and 10 over 1, 1, 2, 5, and 10 over 7, positive or negative, and guaranteed, since they told us there's a rational zero, at least one of these numbers will work. I'm going to go out on a limb and say we could probably avoid even trying these. It's not impossible to write a problem that uses them, but we're learning for the first time, so hopefully they're not going to make it totally miserable for us. I'm going to try one of these random numbers. I do know one trick I'll tell you guys, that if these numbers inside of here, if when you add them up you get 0, if these add to make 0, then this number is going to work. If you add these up and you don't get 0, it's not going to work. These will not add to make 0, so it's not going to work. I'm not even going to try it. I'll try a 2. We'll see what's up with the 2. I have no idea if it's going to work or not. This is looking like it's going to get pretty big pretty fast, actually. I'm going to have 65. It's just going to get bigger and bigger and bigger. This is not going to work. 2 is not going to be the way to go. Maybe a negative 2 will, though. That might balance out some of that craziness we saw. 7 drops straight down. That adds up to make 37 times negative 2 is negative 74. Better check that. Those combine to make positive 9. Then we get a negative 18. Then we get a negative 5. Then a positive 10, and look at that. So my first guess of 2 I could see was going to create out of control and not make any sense. Negative 2, if I drop this down, multiply, put the answer there, add, put the answer there, multiply, answer there, add, answer there. I've got this good. Here's the problem, though. This 7 was 7x to the 4th. So this 7 is 7x cubed. I don't know how to solve 7x cubed without using synthetic division. So this corresponds to 7x cubed, 37x squared, 9, and negative 5. I want to point out that this same list of numbers that we had from before, it's either going to be, we could take some numbers out of here that aren't going to work, because this new polynomial, if I were to write it out, has a constant of negative 5. And so if I look at this list, these numbers can be eliminated as options. So as I continue, what I'm going to do is I'm going to stack this, meaning we need to get this down to a quadratic. So I've got to do another synthetic division till it's down to just the 3 numbers. And I'm going to stack it like this, and I'm going to know not to use any numbers that don't go into negative 5. So we're down to either using 1 or negative 1 or 2 or negative 2 or 5. No, not 2. Get out of here. Why would you even say that? It's either those or the fractions. And I'm going to bet that, again, they're going to help us. They're going to help us by letting us avoid the fractions. Also, any number that you tried before, if it didn't work before, it's not going to work now. So don't try the 1 again. Don't try. If it didn't work, it's still not going to work. So let's try. I'm thinking about negative 1, and when I think about negative 1 just looks like it'll be a disaster. Because let's see. Negative 1 would give me negative, this would become a 30, and then that would be way away from 5. So forget negative 1, forget positive 1. I guess it's going to be 5 or negative 5. And again, I think if I put a 5 here, that's going to it's just create out of control. So I'm going to try negative 5 and hope it works. So let's see what happens. This drops down. I multiply the negative 5 and the 70 at negative 35. This is looking pretty promising. Those combine to make 2. Hey, this looks negative 10. These combine to make negative 1. These multiply to make positive 5. Yay, that worked well. And now, so this 7 was 7x to the 4th. This 7 is 7x cubed. So finally, I've got this down to a quadratic, and we have lots of ways to solve quadratics. And at this point, I'm going to try to factor this, but I can tell you right off, this is not looking too factorable to me. If I try to think of things that would multiply to get these and add to make 2, I don't think it's going to work. So I'm going to use that quadratic formula. It's the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So our other answers will be negative 2 plus or minus the square root of 32 over 14. And here's something we haven't done for a while. We have to clean this up. This 32 is really a 16 times a 2, and I can square root the 16. So I got negative 2 plus or minus square root of 16 is 4 root 2 over 14. And then if all these numbers are even, whoopsie doodle, all the numbers on the outside of the radical, if all the numbers on the outside of the radical have a common factor, you should divide that out. So that'll actually become then negative 1 plus or minus 2 root 2 all over 7. So we have 4 answers to this problem. This is a 0, this is a 0, and then this is 2 more zeros. And our final answer is going to be negative 2, negative 5, negative 1/7 plus 2 root 2 over 7, and negative 1 over 7 minus 2 root 2 over 7. This counts as one answer. This is the second answer, third answer, fourth answer. That was a mouthful, you know. And if this radical stuff's not going well, let me know. I'll definitely give you guys a chance on your test to show your work on these, because I don't think Alex had you practice this enough before now. It's not that bad, but usually it's the kind of thing that I would have had you practice earlier if I realized Alex was going to do it. They didn't give me a chance to give it to you. So we will work that out. Definitely something you should. It's definitely something you should know how to do. We just may need to practice that a bit. So let me know if you have questions on that. Good luck.